have Christopher coming up next. And Christopher, as I mentioned, has been our JavaScript wizard, TypeScript wizard a little bit. He has been transferring from being a JavaScript wizard to a TypeScript wizard over the last year, and also knows a lot about compilers, whether he wants to or not.
Indeed, indeed. So last year, my talk at the summit was entitled Block Definitions, Past, Present, and Future. This year, I'm going to be talking as well a little bit about generators, in particular about our existing generator infrastructure. I only have about 10 minutes, so I'm going to leave out most of the past. We're just going to talk about the present and at least the sort of near-term future of the existing generator code. I think Neil has covered the sort of brief overview of generators, but I will touch on that very briefly. I'm going to show you a bit of code showing how generators are currently defined. Some of you will be pretty familiar with this. I expect some of this might be new. And I'm going to talk about the changes that we're planning to make as part of finishing off our TypeScript migration, because at the moment the generators are one of the few bits of the code base which are still pure JavaScript. So just a little warning, this is definitely a technical talk. There's going to be lots of code, not quite the 40,000 lines of code that Neil had in his little demo just now, but I've had a look through the other slides for the later presenters, and you'll be glad to know that once this talk is over, you've seen pretty much all the code you're going to have to look at the summit today. So generators convert blocks to executable code in a particular language. They're essentially a block-to-code compiler. And the way they're currently defined has three parts. So there's a code generator class, which is part of Blockly core. That has already been converted to TypeScript. Then in the generators directory, we have a file which creates an instance. So for example, Lua generator, which contains all of the code that's necessary to support that particular language, but not any particular blocks. So that includes things like operator precedence tables and kind of code that's useful for generating code for for multiple blocks. And then finally, there's the block generator functions, and there's going to be one of these for each block for each language that we support. And those are the functions that actually put together the strings that are the executable code. As Neil mentioned, we support 5 different languages. In this talk, I'm going to use Lua as the example because Lua is only 3 letters long, and so it lets me fit more stuff on the slides. But everything that I say about Lua is equally applicable to Dart and JavaScript and Python and so on. So here is a very abbreviated version of the code that defines the Lua generator. This code is pretty much mostly unchanged since the early days of Blockly. And it does things in a way that was very typical for JavaScript in the early days, but does create some problems for us going forward. The top section creates the Lua generator object. You can see it's just an instance of the code generator class. We then call a bunch of methods on it to initialize it, and then in particular we add a whole bunch of additional properties. For example, order atomic is the first part of an operator precedence table, and we then add a bunch of methods, and then finally we add, at the bottom you can see we're adding an actual generator function. So this is for the math negate block, which is like a unary minus math function. And there's going to be one of those for each block type. So if you've written generators, this bottom part probably looks fairly familiar to you. A decade ago, this kind of code was state of the art, but as we're looking at migrating to TypeScript, there are some problems that have become apparent. So let's just talk about those briefly. So first of all, TypeScript doesn't really like having arbitrary extra properties added to class instances. It's sort of the idea of classes in TypeScript. You tell it in advance what properties it's going to have, and then you can check to make sure you're using the properties you said you were going to use. And here we just stick a whole bunch of extra stuff on an object. And I mean, you can make it live with that, but it's not very. You're not leveraging the advantages of having the TypeScript compiler helping you. Second of all, in this snippet, you can see we have order atomic, but for the Lua generator, there's like 11 constants like this, and in JavaScript, there's like 36 constants. They look like an enum. They should be defined as an enum, and if we define them as an enum, then the TypeScript compiler could actually check to make sure that we're using them properly. So it would be nice to be able to fix that. This is a bit nitpicky, but oh, I'm sorry, I seem to have missed Oh, my speaker notes are slightly out of sync with the slides. Sorry. I'm just going to say, so we have a problem here with block names. We put the generator functions directly on the generator instance, and so you need to make sure that the names of your block types don't conflict with any of the other methods that we've already defined on the generator object. Fortunately, all of our block types happen to have underscripts in their name, and our style guide forbids having infix underscores in our method names. So far we've been really lucky, but obviously this, if you decided you wanted to create a block named init, it's going to clash with the init function that's init methods that's assigned above. So, and this also makes life difficult for us. If we create new methods, we could accidentally break your code. So, yeah, it's not a great arrangement. And then, yeah, finally, this is a bit nitpicky, but we've got in the body of the generator function, when we make recursive calls, we actually are calling this specific instance, this particular Lua generator. So this method is kind of tied directly to a particular code generator instance. It means that if you wanted to have two different generators for the same language, they couldn't really share generator functions. You need to like redeclare all of the generator functions to create a separate generator for the same language, which is a bit unhelpful. So we can fix a few of these problems in a few different ways, and we're going to have a look at that. In particular, Rachel is really hoping that we'll get the TypeScript migration done in this quarter, and so I have been thinking quite hard about this over the last couple of months, trying to figure out how to make this code more migratable without hopefully breaking any of your existing code. So the first change is mostly for our benefit, and that is to create a subclass of code generator for each different language. And we can then move all of the language-specific properties and methods from the instance, from the particular instance onto the class. So let's see if I have a little laser here. I think you can see these methods here were previously, in the previous diagram, they were actually down here on the instance itself, but they're now part of the class. And that makes the compiler much happier with all of us, and it can actually check to make sure we're calling these methods correctly. The language agnostic code stays on code generator, that doesn't change. But now we have the option of creating multiple instances of a particular language. So you could have, in this case, multiple Lua generators, and it just makes life a bit easier. That solves most of the type checking problems, but we have this generator name clash problem. So the solution to this is we're proposing to create a dictionary object. In this diagram, I've given it the name forBlock. Other suggestions would be welcome. But the idea is we have a little dictionary object that's separate from the actual generator object, and all of the generator functions exist on this dictionary so that their names don't, you can name them whatever you like. They won't conflict with the methods on the code generator itself. The previous change isn't going to affect your code really at all, but this one potentially will if you want to take advantage of this. We can provide some backwards compatibility so that existing code should keep on working in most cases, but I think this is going to be a better way of doing things going forward. And some other minor changes. We'd like to use actual TypeScript enums where we can. We will pass the code generator instance into the code generating functions when we call them. So if they want to make recursive functions, they can use the correct code generator object to do so, if there's more than one in your system. And we're also planning to make some minor changes to how the code generators are accessed if you import the generators using a script tag. And that is for basically, we need to be able to export more than we're currently exporting, so we're going to just need to make some technical changes to that. If you are using ES module style imports, that won't affect you at all. But taken together, these should allow us to provide much better typing information in our d.ts files, the TypeScript type definition files for Blockly, and it should allow you guys more flexibility when defining and using generators. So let's look at some actual code samples here. So this is an updated version of the slide that I showed before with some changes highlighted in it. So the first change is we've created this enum here, so the operator precedence table will actually be an enum. We've encapsulated a bunch of stuff into the Lua generator class here, rather than being attached directly to an instance. And in the bottom, you can see the actual changes that would need to be made to a particular generator function as a result. And I will show a before and after comparison. You can see we have, sorry, wrong button. You can see we have a separate export for the order. So where you're using that, that's available separately rather than on the generator object itself. The generator functions are going into a dictionary rather than directly onto the generator object. And finally, the code generator instance is passed in here so that when we make recursive calls, that can be done in a way that's a little bit more flexible. So these are just the highlights of the changes. There's a lot of detail about this to be cited. You can see on the slides links to a number of GitHub issues. If you write or maintain custom generator code for your product, we would love to hear your feedback about these proposed changes. Please feel free to read the proposals which have more detail and add your comments to them. I'd also love to talk to you in person during the summit. If you're here in person, please grab me during a break. If you're online as part of the virtual summit, do speak to one of the moderators there, and they will hopefully put us in touch. But yes, that's it for me. Any questions?